Astronomers have found clear evidence of what could be an Earth 2.0. This artist rendering shows the rocky planet identified as Proxima b orbiting the Proxima Centauri star.
This is a game changer because astronomers have hit the jackpot. This is their dream come true. A new chapter in astronomy has opened up.
Scientists looking for life on other planets like to talk about the Goldilocks zone, not too hot, not too cold, but just right. And now NASA's found a planet that's right in that zone.
You might be potentially getting ahead of yourself out there, but at this point, scientists haven't actually been able to look at this planet directly at all. They have confirmed it's there by measuring slight shifts in the color of light that's coming from this star. But they have come up with some ideas of what it might look like. This planet is about 1.3 times the size of Earth, so a little bit bigger, but not too much bigger. It's a lot closer to its star than we are to the sun, but its star is smaller and dimmer. So they say that on the surface it would be like perpetual sunset. And they also say that you could walk on it.
We expect and we completely trust that a planet with a mass of 1.3 Earth masses is a terrestrial planet, which means that it is similar to Earth in its shape, sort of, in its making. So it's not a gas ball or something. It's a terrestrial one that has a surface.
A mysterious signal from the closest star to Earth just changed everything. It wasn't random. It wasn't natural. It came from a planet eerily similar to ours. And it might be the first contact with an alien civilization. This is not science fiction. This is real, and NASA knows it. Just 4.24 light-years away from Earth lies a small red star, our closest stellar neighbor. Its name, Proxima Centauri. And orbiting this faint, almost invisible star is a planet unlike any we've found before. Proxima b. It's roughly the size of Earth, rocky, temperate, sitting right inside the star's habitable zone, where conditions might allow liquid water to exist. For decades, scientists have dreamed of finding a planet like this, one close enough to study, and maybe, one day, even visit. But what makes Proxima b truly terrifying is what we just heard from it. In late 2020, a signal was detected. Not just any signal, a narrowband radio transmission coming from the exact location of this alien world. A signal with no known natural explanation. And now, scientists and even NASA are beginning to wonder, was this our first contact? Or are we simply hearing something we were never meant to find? In 2020, while the world was distracted by global events, a quiet discovery was unfolding in the Australian outback. At the park's radio telescope, a team of astronomers from the Breakthrough Listen project was scanning the skies for something extraordinary. Evidence of intelligent life. Their target? Proxima Centauri, the closest star to our solar system, just 4.24 light-years away. Orbiting that star is Proxima b, a rocky planet about the same size as Earth, sitting in the habitable zone where liquid water could exist. And then, a signal appeared. It wasn't just any signal, it was narrowband, centered at 982.002 megahertz. A frequency not associated with any known satellite, aircraft, or Earth-based transmitter. Narrowband signals are incredibly rare in nature. They don't come from stars, black holes, or galaxies. They come from technology. What made this even more chilling was its origin. The signal came directly from the direction of Proxima b's orbit. The transmission lasted for 5 days, remaining consistent and stable. It showed a slight drift in frequency, as if it were being emitted from a rotating planet, a behavior expected from a natural planetary source but completely unnatural for background space noise. Scientists were stunned. This was only the second time in history a signal had ticked so many boxes for potential alien origin. The first was the iconic WOW signal from 1977, but unlike that short burst, the Proxima signal offered something better: duration, precision, and the possibility to study it further. Speculation erupted. Was this a cosmic anomaly? A human-made artifact bouncing back to Earth? Or was it something else? The search had suddenly become very real, and this mysterious transmission had just opened a door humanity wasn't sure it was ready to walk through. To understand why this signal from Proxima Centauri caused such a stir, you need to understand what a narrowband signal actually is and why it's such a big deal. The universe is loud. It's filled with radio waves, bursts of radiation, pulses from stars, and violent explosions echoing across space. These natural signals are broad, chaotic, and messy. They spread across huge ranges of frequencies like static noise blasting from every direction. But a narrowband signal is the exact opposite. It's focused, clean. It occupies just a tiny sliver of the radio spectrum, often less than 1 hertz wide. That level of precision doesn't happen by accident. It requires intentional engineering. Scientists often compare it to being in the middle of a crowded stadium, full of screaming fans, and suddenly hearing a single, clear note played on a piano. Not just a sound, but a signal with structure, deliberate, purposeful. And in nature, that's almost impossible to find. Most known cosmic events, pulsars, quasars, solar flares, simply do not produce narrowband emissions. They're too wild, too spread out. So when a narrowband transmission appears, it immediately triggers interest from SETI researchers, because the only known source of such precise signals is technology. But here's what made the Proxima signal even more suspicious. It wasn't just narrow, it was stable, uninterrupted, and repeated over multiple days. That's something even human satellites often fail to achieve. And it didn't match any known frequency from Earth-based emitters. If someone, or something, is broadcasting from Proxima b, this is the kind of signal we would expect them to use, not for noise, but for communication. And suddenly, a new question began to take shape. If this signal was artificial, what is it trying to say? Detecting a signal from another star isn't as simple as pointing a telescope at the sky and waiting for something strange to appear. It requires an intricate blend of hardware, software, and an almost obsessive level of precision. The Proxima signal wasn't detected by chance. It was discovered thanks to some of the most advanced technology humanity has ever pointed toward the stars. Let's start with the equipment. The Parkes Radio Telescope in Australia, also known as the Dish, has a diameter of 64 meters and is equipped with receivers capable of picking up radio waves from billions of kilometers away. But size isn't everything. What really matters is how it listens. The system used for this detection is called phased array multiplexing. It's a technique that allows multiple antennas or sensors to work together like a single hypersensitive ear. Think of it as combining the hearing of dozens of people to pick out a whisper from across a crowded room. This array increases both sensitivity and directional accuracy, which means astronomers could pinpoint the signal to a precise spot in the sky, right where Proxima b should be. But even with cutting-edge hardware, raw data from space is a storm of static. To make sense of it, researchers rely on artificial intelligence. Powerful algorithms filter out noise, identify repeating patterns, and isolate anomalies. These systems are trained to detect what human eyes and ears would miss, brief, faint blips that don't match anything we know. In the case of the Proxima signal, the algorithm flagged it almost immediately, not because it was loud, but because it was too perfect. The signal's narrow frequency, unusual drift, and duration match none of the standard false positives like Earth-based interference, satellites, or cosmic background noise. It simply didn't behave like a natural signal. And here's what's truly unsettling. This kind of detection system didn't even exist a decade ago. If the same signal had arrived in 2010, we might have never noticed it. It would have been just another data point, lost forever in the cosmic noise. So now the obvious question is, how many signals like this have already passed us by? The Proxima signal may not be the first of its kind. It might just be the first one we were finally capable of hearing. As the technology evolves, so does the clarity with which we can listen to the universe. And now that we've tuned in to this cosmic frequency, scientists everywhere are asking, what else is out there just waiting to be heard? Detecting a strange signal is one thing, but understanding what it means, that's an entirely different challenge. Once the Proxima signal was confirmed to be real and not the result of interference or equipment error, the next step was obvious, but daunting: decoding it. Teams of scientists, mathematicians, linguists, and cryptographers were called in. Their mission? To find out if this transmission was more than just a repeating tone, if it might be, in some form, a message. They began by breaking the signal into its raw components, looking for patterns, simple pulses, repeating numbers, prime sequences, anything that might hint at intelligent structure. One idea was that the message, if real, would be built on universal constants, mathematical truths understood by any intelligent life, no matter their biology or language. Things like the Fibonacci sequence, pi, or prime numbers. These would serve as a kind of universal alphabet to show that the sender knows math, and expects us to too. But here's where it gets complicated. Even if the signal has structure, what if the message isn't meant for us? What if it's a local broadcast, an alien version of radar or radio, never intended to leave their own planet? What if it's not a message, but just a side effect of alien technology? Or worse, what if it is a message, but we're simply too primitive to understand it? Some researchers tried applying tools from linguistics, looking for rhythm, structure, segmentation. Others used machine learning to scan for unknown codes. Even concepts from music theory were tested, in case the signal used tonal patterns instead of logic-based sequences. But despite all the analysis, no clear translation has emerged. And yet, something about the signal still feels deliberate. The consistency, the drift, the origin point. Everything suggests that it didn't just happen, it was built. This opens up a disturbing possibility. We may have received a cosmic hello, and we don't know how to say hi back. And here's the bigger question that no one can answer. What happens if the message wasn't meant for us at all, but we intercepted it anyway? The idea that we're listening in on a private transmission between civilizations far more advanced than we are raises unsettling ethical and scientific questions. Are we intruding? Are we being watched in return? Or was this signal a kind of cosmic breadcrumb placed deliberately, waiting for someone just like us to find it? If the Proxima signal is real, if it was created by an intelligent civilization, then we are standing at the edge of the most profound discovery in human history. This would mean we are not alone. that Earth is not unique, that somewhere, just 4.24 light years away, something else is thinking. For scientists, this isn't just exciting, it's earth-shattering. Entire fields of study would be rewritten overnight. Astronomy, biology, physics, even philosophy would enter a new era. Astrobiologists would begin rethinking the very definition of life. If intelligent beings exist on Proxima b, what do they look like? What kind of environment do they live in? Have they evolved similarly to us, or in ways we can't even imagine? Physicists would scramble to understand their technology. If they can send a stable signal across space, what else can they do? Have they mastered interstellar travel? Do they know things about the universe that we've yet to discover? And then, there's society. The public response would be explosive. Some would celebrate, others would panic. Governments would be forced to respond rapidly. Questions would spread like wildfire. Should we reply? Who speaks for Earth? What do we say? Do we even want them to know we're here? Religious leaders would interpret the discovery in vastly different ways. Some might see it as confirmation of a greater cosmic plan. Others might view it as a threat to long-held beliefs. Education systems would shift. Space science, once a niche subject, would become essential knowledge for future generations. Students might grow up learning not just about planets and stars, but about potential alien societies. Funding for space exploration would surge. Telescopes, satellites, and planetary probes would be launched faster than ever before. Private space companies would enter a new golden age. The search for more signals would become a global obsession. But beyond all the political, cultural, and scientific chaos, one truth would remain: humanity would never see itself the same way again. Our place in the universe would shift from center stage to just one chapter in a much larger story. And maybe that's the most beautiful and humbling part of all. While signals from Proxima Centauri raise new questions about intelligent life, other discoveries are forcing scientists to rethink the universe itself. In recent years, powerful telescopes like the James Webb Space Telescope have captured light that's been traveling through space for over 13 billion years, light from some of the earliest galaxies ever formed. And what we've seen doesn't make sense. Some of these ancient galaxies are far too massive, too organized, and too mature for their age. They formed just 300 to 400 million years after the Big Bang, a period when, according to our models, the universe was still chaotic and unstable. It's as if entire galactic cities rose overnight, when science expected only scattered stars. Even more puzzling are the supermassive black holes found at the centers of these galaxies. They appear to be merging, growing, and evolving faster than physics says they should. This forces a troubling possibility. Our understanding of the early universe, of how everything began, may be incomplete, or worse, fundamentally flawed. Were conditions after the Big Bang more favorable to rapid creation than we thought? Are there unknown forces or dimensions at play? Could the universe be shaped by principles we've yet to discover? Some theorists are even questioning the timeline of cosmic evolution. What if the early universe wasn't as primitive as we believed? What if intelligent life emerged much earlier than we ever imagined? Suddenly, the idea of civilizations older than Earth, older than our sun, becomes more than science fiction. It becomes a cosmic probability. And just like the Proxima signal, these ancient galaxies whisper the same question: what else are we missing? Simply because we don't know what to look for. Our entire understanding of the universe is based on one simple limitation: what we can see. Astronomers call it the observable universe, a sphere of space about 93 billion light-years wide, shaped by the speed of light and the age of the cosmos. Anything beyond that? It's invisible, untouchable, unknowable. That's because the universe is expanding, not slowly, but accelerating. Some galaxies are moving away from us faster than the speed of light, which means their light will never reach us. Not now, not ever. Beyond the cosmic horizon, there could be countless other galaxies, entire structures, maybe even other forms of life. And that's just what we can't see. Even within our observable slice, we're only scratching the surface. Most of the universe is made of dark matter and dark energy, mysterious forces we don't understand, can't detect directly, and yet they shape everything. It's like looking at a painting, but only being able to see 5% of the canvas. Some scientists now believe the universe might be infinite, not just in size, but in possibilities. If that's true, then somewhere out there, every variation of matter, energy, and even life could exist. Another Earth, another you, another civilization, perhaps far more advanced than our own. And here's the real mind-bender. They might be looking at us the same way, just beyond their observable edge. As our instruments improve and our reach extends, we're beginning to sense the scale of our cosmic ignorance. What we know is vast, but what we don't know is far greater. And in the spaces we can't see may lie the answers to everything. To unlock the secrets of the universe, you need to see farther than ever before. And that's exactly what the James Webb Space Telescope was built to do. Launched in December 2021, after more than 2 decades of planning, design, and delays, the James Webb isn't just a telescope, it's a time machine peering back billions of years to witness the birth of stars, galaxies, and maybe even life itself. Unlike the Hubble, which sees mostly invisible light, Webb operates in the infrared spectrum. That means it can see through cosmic dust into places where stars are born, regions that were completely hidden until now. Its 6.5-meter mirror, made of 18 gold-coated hexagonal segments, is so sensitive it can detect the heat of a bumblebee from the moon. And it doesn't orbit Earth. Instead, Webb sits at the second Lagrange point, a stable pocket of gravity over 1.5 million kilometers away, far from our planet's noise and warmth, kept cold by a 5-layer sunshield the size of a tennis court. But what makes Webb so extraordinary isn't just its engineering, it's what it's already found. In just its first year of operation, Webb captured images of galaxies formed only 300 million years after the Big Bang, far earlier than scientists expected. It found giant black holes in galaxies that shouldn't exist yet. It detected clouds, storms, and potential water vapor in the atmospheres of distant exoplanets. Some of those planets lie in their star's habitable zone, and the data Webb gathers could reveal biosignatures, chemical signs of life. We're not just looking at pretty pictures. We're scanning alien skies, measuring alien air, searching for alien fingerprints. And Proxima b? It's on the list. Though Webb can't yet image it directly, its spectrometers may one day help us analyze its atmosphere, temperature, and composition. If there's life there, plant-based, microbial, or something far more complex, Webb might be the first tool to catch the evidence. The telescope is not just redefining what we know, it's reshaping how we search. With every image it sends back, The line between what we imagine and what's real gets thinner, and the universe gets a little less silent. The discoveries we've made so far, from ancient galaxies to mysterious signals, are only the beginning. What lies ahead could be even more revolutionary. Right now, space agencies and private companies are planning missions that just a decade ago sounded like science fiction. Probes designed to reach the Alpha Centauri system, including Proxima b, are already on the drawing board. One project called Breakthrough Starshot aims to send ultralight, laser-powered spacecraft traveling at 20% the speed of light. That would get us to Proxima Centauri in just 20 years, not centuries, not millennia, 2 decades. And once there, those tiny spacecraft could capture the first real images of Proxima b's surface, clouds, oceans, land, cities. Meanwhile, back on Earth, AI is transforming astronomy. Machine learning now scans terabytes of cosmic data every day, looking for anomalies, classifying exoplanets, and identifying potential biosignatures in real time. Soon, telescopes will work like intelligent systems, not just observing, but thinking, analyzing, and reacting as new data arrives. And collaboration is key. For the first time in history, space exploration is no longer driven by one nation or one agency. NASA, ESA, JAXA, private companies like SpaceX, and Blue Origin all are sharing data, launching missions, and moving toward a common goal: finding life. We're not just asking, "Are we alone?" anymore. We're preparing to answer that question, and with every new signal, every new planet, every new scan of a distant star, we get one step closer to understanding our neighbors in the cosmos, closer to knowing our place in the vast interstellar web of existence, closer to a discovery that could change humanity forever. The signal from Proxima b may fade, but its echo has already changed us. Because whether it was a message, a mistake, or something we were never meant to hear, it reminds us of something deeper. We are listeners in a universe that may be speaking. And every discovery, from a whisper in the stars to a distant ancient galaxy, pulls back the curtain just a little more, not to show us answers, but to show us how many more questions remain. Are we being watched? Have we already been contacted and missed it? Or is this just the first knock before something or someone arrives? Whatever the truth is, one thing is certain: the silence is breaking, and this is only the beginning. And in the next video, let's just say, you won't believe what we found next.